So on this video, we're gonna do evaluate composition of inverse trigonometric functions without values, with values, about outside the unit circle. Now, this example right here, sine of tangent inverse of a divided by 3. Um, so this is the technique for these type of problems. First, I'm gonna assign this inside sine as an angle, right? So sine, so theta, that's an ugly theta. Oh, yeah. Theta equals tangent inverse of a over 3. And why can I do this? Well, notice that tangent inverse of anything is going to produce an angle. Call it theta. It could be alpha, beta, x, y, z, w, whatever you want. Now, that being said, I'm going to use the inverse definition, the if and only if statement. Tangent of theta equals a over 3. Okay, and then once we are here, we can use SOHCAHTOA to find the extra value that we need. Now, what is tangent? Tangent is opposite over adjacent. So let's say this is theta here. The opposite is the letter A, and the adjacent is 3. But now we're looking for sine of theta. Now, why am I looking at sine of theta? Well, because theta is equal to tangent inverse of a over 3. So we can plug into this equation. And now, what are we missing? We're missing the hypotenuse, right? Since sine is opposite over hypotenuse. And how can we find the hypotenuse? Well, we will need to use Pythagoras theorem. So it's going to be 3 squared plus a squared equals c squared. Okay? And now, what is c? Well, c is going to be the square root of 9 plus a squared. Okay? So, let's continue this fact. Theta is going to be opposite over opposite over hypotenuse. So it's going to be a over the square root of 9 plus a squared. Notice it doesn't matter what a is as long as it fits in the domain of sine, okay, and the range of tangent inverse. So that will be the answer for the first one. So let's do another one. Now we can see already it's getting a little bit more complicated, but it's still the same principles. Take theta to be sine inverse of p over the square root of p squared plus 9. That means that sine of theta equals p over square root of p squared plus 9. Now we create a triangle, a right triangle. We write theta there. Theta is opposite over hypotenuse. Now we're looking for tangent of theta. Well, what would I need for tangent? I would need the adjacent. So let's call this guy, let's call it y. Okay. So we use Pythagoras once again. So it's going to be y squared plus p squared equals radical p squared plus 9 squared. Okay. And now we get y squared plus p squared equals, well, the square root squared will get rid of the square root, so p squared plus 9. I'm isolating for y because that's the adjacent, that's the one we need. So y squared equals p squared minus p squared plus 9. Y squared equals 9, therefore y equals 3. So that will be the adjacent. Therefore, tangent is opposite over adjacent, which is p over 3. Okay, and that'll be the answer for that one. Now let's increase the complexity by finding half angle and double angle formulas. So again, same technique. You write theta equals sine inverse of radical 3 over 2. Okay. Now, here is not necessarily needed to write it like this because we know what sine inverse of radical 3 over 2 is. Well, pi over 3. So this one is asking for cosine of 1/2 times pi over 3, which is just cosine of pi over 6. Right? We multiply across. Now, cosine of pi over 6 is radical 3 over 2, which is your answer. Now, for this one, it's a little more challenging because this one is not in the unit circle. So, sine of 2 cosine inverse of 3/5. Well, again, theta equals cosine inverse of 3/5. This implies that cosine of theta equals 3/5. Now, here we're looking for sine of 2 theta. Okay, and we have to use our identities. The sine of 2 theta is 2 sine of theta cosine of theta. That means that we need to find sine. We already know what cosine is. We need to find sine. So this one we use SOHCAHTOA once again. Cosine is adjacent over hypotenuse. So in order to find sine of theta, we need the opposite. So that's using Pythagoras. 3 squared plus b squared equals 5 squared. 9 plus b squared equals 25. B squared equals 25 minus 9, which gives you 16. Oop, my bad. And b equals 4. Okay. So sine of theta is opposite, which is 4. So 4 over 5. So this becomes 2 over 1 times 4 over 5 times 3 over 5, which gives you 12 times 2, 24 over 25. And that will be your answer. Okay, that will be everything for now. If you have any questions, leave them in the comments below. Don't forget to visit us at www.multiwell.com for books, tutoring services, and more videos. Thank you for watching. Have a good day.